So next question is, if y is equal to a into e to the power of nx plus b into e to the power of minus nx, then prove that y double dash is equal to n square into y. Means here we have to do the second derivative. So in the solution, if you take, given that y is equal to a into e to the power of nx plus b into e to the power of minus nx. Now differentiating with respect to x on both sides. So now d by dx of y, which is nothing but y dash. So d by dx of y is equal to, so d by dx of e to the power of a into e to the power of nx, a into e to the power of nx plus d by dx of, so b into e to the power of nx. See, with respect to x, now dy by dx is equal to, dy by dx is nothing but y dash, so which is equal to, a is with respect to x a constant, so that's why a into d by dx of e to the power of nx plus, so here b is also constant with respect to x, so b into d by dx of e to the power of minus nx. See, observe here, so dy by dx is nothing but y dash. Dy by dx is nothing but what? First derivative, that is y dash, which is equal to a into, see, e to the power of nx. So we know the derivative of d by dx of e to the power of x is equal to, so e to the power of x. So e to the power of nx means also a into e to the power of nx, a into e to the power of nx, so into derivative of d by dx of nx, d by dx of nx. Similarly here also b into e to the power of minus nx, derivative is e to the power of minus nx, and again, so d by dx of minus nx, d by dx of minus nx. So now y dash is equal to, so a into e to the power of nx into derivative of nx is n plus b into e to the power of minus nx into derivative of minus nx is minus n. So yeah, minus n into derivative of x, derivative of x is 1. So we get here y dash is equal to, so here n is common in both, so you can take n common, so n into a into e to the power of nx, a into e to the power of nx, plus into minus is minus, so b into e to the power of minus nx, b into e to the power of minus nx. So now again differentiating with respect to x on both sides, again differentiating with respect to x on both sides, we get here, so y derivative of y dash, second time we are doing the derivative, so that is y double dash is equal to, so here n is a constant, into d by dx of, so a e to the power of nx, and minus, so here, so b is also a constant, so that's why d by dx of, so b into e to the power of minus nx, So now here, so which is n into d by dx of a into e to the power of nx and minus d by dx of b into e to the power of minus nx. So which can be written as n into, so again here also same like this. So a is also a constant. So a into, so d by dx of e to the power of nx, minus b into, again b is also a constant, so that's why b into, So d by dx of minus nx, d by dx of e to the power of minus nx, d by dx of e to the power of minus nx. So we get here y double dash is equal to here n into, so again here a into d by dx of e power nx. See here d by dx of e power nx, which we are getting n into e to the power of nx. Same directly I am writing here n into e to the power of nx, and similarly here minus, so minus here d by dx of e power minus nx, which we are getting, that is we are getting here minus n into e to the power of minus nx. So that's why here minus b into minus n into e to the power of minus nx we get. See, observe carefully here. So here n into a into e to the power of nx derivative is here e power nx, and again d by dx of nx derivative is n. So that's why finally we are getting n into e to the power of nx. So I wrote here directly n into e to the power of nx. Similarly here, so b into e to the power of minus nx also. So we get here minus b into n into e to the power of nx. So that's why I wrote here also directly minus n into e to the power of minus nx. So finally, if you see that within the bracket also we have n is common, so which is equal to, so if you take the n common within the bracket, we get n into n is n square into here a into e to the power of nx, and minus into minus is what here, plus b into e to the power of minus nx, we get clearly observed here. N I have taken the common, so then n into n is n square. So n square into here a into e to the power of nx, and here minus into minus becomes plus. So b into e to the power of minus nx. See, observe here. So a into e to the power of nx plus b into e to the power of minus nx is given y. So that's why here we can write, so therefore y double dash is equal to, we can write that n square into, this entire thing is replaced by a into e to the power of nx plus b into e to the power of minus nx is replaced by y. So that's why finally we can write y double dash is equal to n square into y. So clearly here, since y is equal to a into e to the power of nx plus b into e to the power of minus nx, which is the given function, so that's why we can write y double dash is equal to n square into y. So like this, when y is given a into e to the power of nx plus b into e power minus nx, we can prove that y double dash is equal to n square into y. Next.